especially on a Saturday. Lovely to see people here. Thanks for choosing to come to my session. There's many other better sessions I'm sure you could have been to. Yeah, thank you. So, we're going to talk about scaling .NET applications on Azure. Everything I'm going to tell you today applies broadly. So if you're not doing .NET, that's absolutely fine. If you're not doing Azure, that's absolutely fine. These are just the two examples I'm going to be using and talking about, but I think the key concepts still stand. You can apply these to anything. By a show of hands in the room, or a cheer maybe, who's using .NET?
Yo!
Awesome, good. I think it's the best language out there at the moment, but I'm a bit biased. And who's using Azure as well currently? Good. Sort of equal numbers. They go hand in hand nowadays, don't they? This is me. I'm Callum. I'm a four-time Microsoft MVP. I also work with a .NET-based CMS called Braco. It's a really good CMS platform. If you haven't heard of it, I'm going to mention it a bit later as well. I'm a .NET developer by trade. I speak at quite a lot of events and organise some of my own too. Love donuts, beer, pasta, those sorts of things. The pandemic didn't really do that good for me, but no. I also day-to-day run my own company. I'm based in London, so we have a small digital agency building .NET and Azure solutions, basically. So here we go. We're going to talk about these 3/4 aspects of scaling your application today. So whenever you're hosting an application, there's always compute. You need server power to actually run your application. Generally also, you'll be storing something or reading something from storage. So persistence matters. Persistence could be a database, it could be images on a disk for a website, it doesn't really matter, but we're going to talk about storage and how that works at scale. State, I'm not going to talk about so much, that's why it's slightly greyed out, but it is equally important, so we'll touch on it. And then I would say the most important aspect of this when you're scaling an application is observability. So the observability aspect informs what you do with the other three, basically. Unless you know what's going on in your application in the cloud, in production, you can't really make informed decisions about how you're going to scale your compute out or where your bottlenecks are, that sort of thing. So let's talk about compute. In Azure, compute looks maybe three different ways. You have virtual machines, hands up or a cheer. Who's running virtual machines in Azure still? A few people. Typically, we've been moving away from this because it requires you to manage physical servers, more or less physical servers. And it's not, well, every time I've had a security audit done, we get called up on having our own managed infrastructure that we manage. So we've tried to move over to more PaaS products like App Service. So App Service is the equivalent of like Google App Engine or AWS Elastic Beanstalk. It's chuck your application at it and it will run it and scale it for you, which is really nice. It gives you a fair amount of control, but also hides it behind a really nice interface and some friendly APIs, so you don't have to worry about what's going on under the hood. And then you've got, I would say the cool kid, but I'm not sure if it's really that way anymore, Kubernetes. So if you were to run an application at scale or ask pretty much any startup nowadays what they're doing, they'll say Kubernetes. It's a cloud native way of hosting containers across multiple servers and then distributing work that way. So when we're talking about compute, these are really the three areas I'm going to be talking about today. You can see how you would scale each of these aspects. A virtual machine, if you need more power, you either add more compute power behind it, or you have multiple virtual machines. You have to manage that deployment of several virtual machines. With App Service, wanting to scale, you're looking at adding more compute behind the scenes, but they manage all of that for you. So it's behind a couple of nice APIs, they handle all of the load balancing and the distribution for you, which is nice. And then Kubernetes is kind of a combination of both. You still have to deploy out servers under the hood, but Kubernetes will allow you to distribute your application more evenly across that server capacity that you've got. We're going to look a little bit closer at these in a bit. Persistence, SQL, or disks, as I said. Typically, this is what you would, we call storage. So in Azure, you've got your traditional like spinning disk type disks or disk services, which is just giving you access to a drive. And then you've got these more modern API-based storage services like blob storage or block storage in AWS or S3. You may have, if you've been running Microsoft applications on premise or on a VM even, you may have self-hosted SQL instances. Well, Azure has the equivalent of a hosted SQL instance that they manage. So just like App Service, you don't have to deploy infrastructure anymore. And then you have this sort of hyperscale, global scale, hybrid database, Cosmos DB, that allows you to do relational tables, a bit like SQL, but it's also got graph databases and NoSQL databases and that sort of thing. So it's super powerful. It can be deployed globally. It can be kind of fault tolerant, where say SQL is a little bit more difficult to make work in that way. The same goes for blob storage. It's a managed product rather than a disk, which doesn't scale well. You have to do a replication and stuff yourself. So we're going to talk about these things as well. And then finally, observability. These are the two big observability products probably in the Azure space. You've got Azure Monitor, that if you're using Azure, you may not have even heard of. It underpins pretty much every service. And any service you go to in the Azure portal, you see a little graph that shows you how much activity your service is getting. That's powered by Azure Monitor. So you're using it and seeing it without really knowing, but there's some very powerful tools you can unlock by diving deeper into the insights it gives you. And then application insights. I'd call this a log aggregator, but it's probably not really fair. So it's telemetry for your application. It's logging a lot of information to one place, making it queryable, and allowing you to draw that valuable information about how your application runs in production. So, when to scale? This is kind of the million-dollar question, or maybe it's a million-dollar question if you get it wrong. When should you scale? You could say, well, my application needs to scale when our requests go up. We have more people asking for our service, so we need to scale our application. But that implies that your infrastructure scales in a completely linear way. More users means more resource needed. That's not always the case. It might be that if you have a read-heavy application, actually you don't need to scale out your databases and all your persistence layer, but maybe a cache is like a Redis cache, for example, is the thing you need to be scaling. So you really need to start to think, what does my application do when it's under load? Equally, if you've got a write-heavy application, you're going to need probably more front ends, you're going to need more compute behind the scenes, and database capacity, for example, but maybe you don't need so much CPU. You could monitor request performance. This is an interesting metric I've seen people decide. So they say, okay, we don't care that our application can handle, say, 1,000 users concurrently. We care that the application responds in 100 milliseconds. And you constantly track that metric. So if your application suddenly doesn't respond in 100 milliseconds, you say, okay, we need to scale at that point. But this is slightly flawed, because if you depend on, say, a third party directly, which you probably shouldn't be, but applications do, or if there's latency, say, within a data center, Azure occasionally has issues. A lot of these metrics can then start to affect your own tracking, your own analytics. And it doesn't necessarily mean that you need to scale. If a partner or Azure is having an issue, chucking more compute at it isn't going to fix it if there's something going on the network, for example. By resource usage, this is sort of what I was getting at with the first point. You can monitor how much CPU or memory your application is using. That's awesome. That might be a good metric. But not every application or every process or every part of your application is built equally. So if you have a CPU-heavy application, say when our CPU spikes to 80% and sits there for a while, we need to scale. Maybe you don't. Maybe that's a typical workflow. Maybe you have a batch process that runs, say, overnight, and it uses up a lot of memory to do that. That's perfectly fine, perhaps. But you need to make sure you're setting your metrics properly, and setting your targets properly. The other two at the bottom, I think people would be reluctant to admit that this happens, but it does happen, and probably more than you think. People that scale applications on a schedule. So, okay, our peak traffic is at the weekend, so we scale up at the weekend and we scale it down on a Monday. Like, fine, that's okay. It's not so dynamic. You know, maybe one time you'll get a peak on Tuesday and your site, then your application can't handle it. What do you do then? That's sort of where the previous points actually lie. but on a schedule is a perfectly valid way of scaling. You might decide that you don't need your dev environments at the weekend, so scale those right down so they don't cost you anything. That's perfectly fine. You just got to have a think about when that really applies. And manually, this is kind of what the GIF aligns with. Everybody has had someone from marketing come in. Oh, we've just sent an email to like 1 million customers. It's going to be okay, right? Like, if you let us know, maybe we could have done something, but probably at this point, it's a bit late. Your only option at that point is to go in and chuck a load more resource at things if you can to scale it. I think the honest answer here is it depends, as with everything in software. You've got to choose what fits your application best, and you've got to understand exactly where your application's constraints are. So use profiling tools and monitoring tools to work this out. That observability point I mentioned at the start, that's where this becomes hyper critical. I was just going to quickly show you application insights as an example. This is a live website we've got right now. It's a moderately high traffic site. It's got a CDN in front of it, thankfully, so it's not really doing too much. But we can see in real time our error rate and this sort of thing. You'll have seen software teams with this sort of board up on a screen in there, like around their desks, for example. People monitoring this, keeping an eye on it. It's a pretty good way of just getting a gut feel for how your application is actually behaving in production. You can see how many requests you're getting. You can see how that correlates to errors or how that correlates to request performance. It's something we should probably be monitoring more actively. Things like Azure Monitor can give you actual alerting when this happens. So send you an email and you had a reduced or degraded performance of your request performance, for example. But choose your metrics and choose them wisely. We'll come back to this. Okay, I said I was going to talk about Umbraco. Umbraco is an open source .NET CMS. It's excellent. If you're looking for a .NET CMS, I highly recommend it. But you don't need to know about that today. For all purposes, this application is a ASP.NET Core 7 application. Typically, I'd host that with a MySQL database, and that would be probably on a server. If I'm running locally, that's definitely on a local local SQL instance. I've decided I'm going to put it on an Azure VM to host it. It's got an SSD where I keep my assets, my static files, and my logs. And yeah, I've got an Azure DevOps pipeline that can build and deploy that application. It's just a .NET application. So when I want to scale this, what do I do? I think I said before, your only option at this point is to just add more tin, put a bigger server behind it, or to maybe distribute that across 2 servers and have a load balancer in front of it. It's not really the Azure or the cloud or the modern way of doing things. So that's kind of what we're going to look at today. 3 ways to skin a cat, 3 ways to scale this example application in Azure. The first one is Azure Web Apps. It's platform as a service. There's no servers. I don't have to manage my virtual machine, which is excellent. It's more likely to pass a security audit. It also includes a bunch of very helpful tools like manual and auto scaling. So with the click of a button, or on a schedule, or when a certain metric gets hit, I can scale my application up. To scale my disks, I can move all of my static files to something like blob storage. Again, fairly infinitely scalable. I move my locally hosted SQL instance onto Azure SQL. No configuration or code changes needed. It's just a different way of hosting SQL. And I can put all of my logs in application instance. This is pretty straightforward to do. Like I don't actually have to do much to change my application. The inbuilt .NET logging will log straight to application insights if I wanted to, with a small amount of configuration. The database is just another SQL database. The storage thing might be a bit more complicated, but that doesn't hugely matter. As an example, I have deployed a number of example applications just to show you the key concepts here. So I have a web app deployed to Azure. It's not got any content in it. This is just a blank default page. This would be an hour talk. I have a full-blown demo with how you deploy that, but for time, you have to skip ahead, sorry. So yeah, this is Azure Web Apps. I have all my configuration options in here, but most importantly, I can scale my app up and out. Up meaning make the app itself bigger, and out meaning add more replicas of that app. So scale out allows us to decide when it loads. Yeah, decide some rules for how I want to scale that. I could just scale that manually all the way up to 10 in this case, or I can do this based on rules. Yeah, that's fine. Cool. So when you do it based on a rule, this is where all of those insights about how your application performs really matter. I mentioned Azure Monitor underpins everything in Azure. This is very much the place where you start to see that apply. So we can add a condition to our scaling and say, yeah, you can do it on a schedule, or we can scale based on a metric. And we can say, I hate that interface. We can say by a number of different metrics in our application and how it's performing, when we should scale up or down, or in or out. A lot of the ones I mentioned already, CPU usage or memory usage, request queue, which is quite a good metric, because if you've got people waiting to be serviced, you know probably your server can't handle it. But there's a ton of different metrics in here. Every time you choose a different one, it's going to show you a graph, sort of what that historically looks like for your application. But it's very easy to just think, okay, it will never hit 70%, so we're going to set it at that threshold. If your application typically uses 70%, say during start when it's booting up, then you're going to end up scaling out unnecessarily whilst the application boots, because it's using more resource than you've configured it to. So you have to sort of decide where your levels are there. Typically, yeah, our applications are quite CPU constrained, so we'd be looking at a CPU metric there for our websites that we're running, for example. If you were doing a line of business app that's just saving stuff to a database, it might well be a request queue that's more important. Microservices, every microservice is going to be completely different. Yeah, there's so many different ways you could decide to scale. But in this case, it gives you a bunch of stuff out of the box, which is really nice. And with a couple of clicks, I can say, yeah, that's all good, add that as a rule, and when that rule is met, increase the instance count by 1, and then don't forget to always add another rule to scale it back down as well. Otherwise, you'll just scale up and up and up and up. We've seen this before, clients go, why is our Azure bill so high? Why have you got 10 instances of that thing running? Because you didn't understand how the scaling rules work. But yeah, it's fairly straightforward to set up. A couple of clicks, and you have an application that scales automatically. Provided you've removed all of those, let's call them static resources that you might need, storage, assistance. As long as you put that somewhere that all of your instances of your app can talk to reliably, that can also scale, your app should scale fairly effortlessly. Okay, so now let's talk about containers. Containers is kind of trendy still. It's been, obviously the concept's been around for a very long time. I feel like more and more software teams are coming around to the idea that this is the way to be building and shipping applications. So if you are using Docker, you can deploy that Docker container now directly to Azure and directly to Azure App Service. You do not have to run Kubernetes to run containers, which is, I guess, really nice. From this exact same example, I've not had to change anything. You can see like the concepts remain the same. Don't containerize your persistence when you're hosting with web apps. Put your storage in blob storage. Use the Azure services that are available to you. Put your database in Azure. Use App Insights to get visibility of how that application performs, and off you go. Well, it's not quite so simple. We have an example here of just a Visual Studio solution, and I was going to show you very quickly how I would. It's a sample.NET app. That's quite small, isn't it? Sorry. If you install the Docker extension, you can add container support. My eyes are tricking me. Anyway, doesn't matter. We'll, for the sake of time, you can literally right-click on a project in Visual Studio, say add container support. It will bootstrap everything you need to build and run your application in a container, which is fantastic. I've not had to know anything about Docker necessarily to make this work. I've just had to right-click, click a button, and off you go. You can make your DevOps pipeline build and deploy that container to something like a container registry. We'll talk about those in a minute. And then, yeah, you're able to deploy that application as many times as you want to as many services as you want. Containers. So I've already said this: install Docker on your local machine, and you can create a Docker file. You don't have to do that. You can just run the commands baked into Visual Studio or VS Code. This allows you to package up your application and infrastructure, but if you're hosting in the cloud, I'd probably suggest not packaging up your infrastructure. It doesn't make sense. Store your image in a registry, so that the result of building a Docker container is called an image. Store that in a registry, and then deploy that image to a container orchestrator of your choice, a place to host it. Kubernetes, Azure Web Apps, doesn't really matter. Of course, there's commands you can do this too. Go all through the command line. Docker build, Docker run, so you can actually run your containers locally. Docker push to deploy that to an external place. And yes, these are the exact same commands you would run in a build pipeline, for example. So yeah, it's fairly simple to get that up and running. For sake of time, we'll move on. But I did wanted to show you a demo. Sorry. I have a container deployed here. This is a application running in Azure on a container. Again, it's a basic getting started container. You don't need to worry too much about what it's doing. But critically, unlike, say, Kubernetes, which we're about to see, you can scale this. You have the same controls as you had with all of the other products. So you can do rule-based scaling, and it just works in the exact same way. There's no learning or changes you need to make in order to host a containerized application. Azure buries all of that behind the scenes for you, so it's quite nice. Okay, AKS. So Azure has a really nice way of hosting containers, also called Azure Kubernetes Service, AKS. It is managed Kubernetes, meaning I don't have to deploy Kubernetes to 10 servers, manage the installations of that myself, manage patching those servers myself. Behind the scenes, it is just deploying Azure VMs for me, but it effectively manages that whole cluster. Think of AKS as a control plane across other Azure infrastructure. So here, they're going to scale out your cluster, which is your servers, and then pods. Pods are a concept from Kubernetes where it's your application and its dependencies, effectively a container deployed in multiple places. So you would deploy a pod across, say, a cluster, and say I need this many instances of it. The one catch with Kubernetes, by default, is it's not designed to be publicly available. So it's designed for microservices, hosting many different copies of an application alongside each other in some infrastructure, but not necessarily for like a web application, those being public and available to you. So if you're running this in Azure, you do have to provision something like an application gateway in front to do all of that networking bit for you that App Service really does. So there's an additional step if you're going to host something in Kubernetes. Now, if you've containerized your application like I did in the previous step with Docker, you can already deploy to Kubernetes and AKS with relative ease. So I have a Kubernetes service already set up. And it was literally a case of going into here and saying AKS, and it tells me, the search is rubbish. AKS, create, and then you can start to configure this. You can choose your presets. They've got a bunch of really nice presets if you don't want to spend a lot of money, just want to play around with this. Dev test is actually fairly handy. You give it a name, choose your region. You choose if you want to have like an SLA as well. And then we can start to configure, what's needed behind the scenes. This agent pool allows me to choose the operating system it runs on, if that matters for your application. Allows you to choose the size of each of those servers behind the scenes. In this case, these are just other VMs. So think of this as I'm going to scale out 5 times. I'm going to have 5 VMs. You can pay for 5 VMs, but you can then utilize that infrastructure for a lot more things than just one application. You can allow it to auto scale. So AKS has this baked in, which if you were self-hosting Kubernetes, it does not do that like you. It understands the infrastructure and what it needs to provision to do that. These recommended node counts are based on the tier that you selected in the previous step. So I've selected a dev test. It's like, okay, that's fairly fine. But it can literally go to like 10,000 nodes behind the scenes if you really need to. So if you need proper hyperscale, AKS is probably quite a good way to do that, and it will allow you already deployed this. It takes a couple of minutes to actually deploy. So I have I had my AKS. It's not there. Is it in a different resource group for some reason? You know what? I'll create one. Why not? So AKS, go and create a service like I was going to do. We'll just give it a name here. Scaling Azure AKS. Apparently it's not there. Oh, well. Yeah, North Europe. Select everything. I'm not going to configure any of the node pools specifically, but it's decided how many servers it thinks I need, and we're just going to go ahead and create. I don't know that much about Kubernetes, and I think this is the beauty here. I've not had to understand anything other than really how much server space there. So all I've provisioned is 5 servers that are on a certain tier that's going to go deploy a bunch of VMs for me, and then I'm kind of away. I have to deploy my application to it, which I can show you in a second, but it's like a genuinely quite easy thing to do to get up and run. We'll let that run for a second, I'll come back to it. The final one I'd like to show you is a hybrid of the two, Azure Container Apps. So this is serverless, completely managed Kubernetes with that same like friendly control you get from Azure Web Apps, but without any of the configuration. So I don't have to know about Kubernetes here. It allows me to deploy a container on a more micro scale, so I can, rather than deploying VMs, literally just pay for the compute I use in a more serverless fashion. I think it's in half gig or 0.5 gig increments of memory, and again, I think in either core or half core, or even lower than that, units of compute. So actually it's really, really quite flexible. If you're doing microservices, this is probably the way to use microservices in Azure now. It's really nice. If you're hosting like a web application, possibly not. You probably want the dedicated compute there. It's Kubernetes under the hood, which is awesome. And it allows you to do scaling with something called CADA, or Kubernetes Event-Driven Architecture. It's effectively something that's in the Kubernetes cluster under the hood already, but you can use the events that broadcasts to decide to scale. It's also got built-in data support and some other concepts that have maybe copied over from Azure Web Apps, in that it's like you can have weighting of where traffic goes and manages traffic. So very quickly, I'll show you that. So I have my resource group, I have my container app environment here, and we can go to apps and we can deploy the app. It's as simple as literally giving it a name, as we did before. Just Azure App. Choose a container. I can either choose one from a registry like Docker Hub, or from Azure Container Registry. In this case, I use the quick start. You can see the amount of compute that it's recommending I use, and I can create, and literally within a couple of seconds, it will go deploy that, and we're away. So, yeah, I'm running out of time, so I won't actually show you the deployed application. But essentially, the controls are exactly the same as Azure Web Apps, which is fantastic. A quick comparison then. So App Service is really plug and play. It's nice and easy to get started. You don't need to know anything. You just deploy your application and off you go. Auto scaling is really painless, provided you understand when and why you should scale. Look at those metrics in App Insights, for example. It includes public DNS, so it's perfect for doing something like a web application that will be publicly available at the customer. It's fairly expensive though. You pay for resource that you might not be able to utilize all of. If your application uses, let's say, 3 gig of memory, you have to pay for the 3.75 gig of memory. So you're paying for a bit more compared to like container apps or Kubernetes, but you can really max out and utilize more of that infrastructure. Kubernetes, you need to know a little bit about Kubernetes and the concepts there, but I think AKS makes it pretty easy. Scaling is fairly manual in that you have to decide how your application is spread across the cluster you've got provisioned. So you can scale the compute under the hood, but it's a configuration thing at the end of the day. If you're doing anything public, you have to have a gateway in front of it. But the benefit here is it can be probably the most cost-effective way of hosting in Azure, because you can really eke every single megabyte out of your capacity. And finally, container apps. It's your infrastructure as an app deployed as in deploy your container basically, but you don't have to manage anything to do with containerization. I didn't show you the scaling stuff there, unfortunately, but it's effectively the same as app service, plus all of the power that Kubernetes gives you exposed through a written message interface. It includes public DNS by default, and it's effectively a PaaS product. So it's pretty cool. In all of these cases, you should use the Azure PaaS like SQL and logging tools. They're great. Container apps is really cheap too, so go check that out. That's me. Thank you. I'd love to have a chat and some questions afterwards. Of course, I know this has been a whistle-stop tour. Like I said, it's kind of an hours-long talk. I'm actually trying to condense it 30 minutes. Love to know how you're hosting your applications, any challenges you have. I'm still on the Bird app. If people are, you can find me there. Otherwise, GitHub or LinkedIn around. Thanks very much for listening. Have a great rest of your day.